Hi there, folks. This is the Unit 4 review, and I am the amazing Mr. Jansen, so away we go. If we take a look at this first one, it's just asking us to find the slope of each of these. So I'm just going to use my slope formula on this first one. Remember, the slope formula, slope is always m, and the slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And now I just plug these values in. So let's see, the second y value right here is that 2 minus the first y value, which is the -8. And make sure you keep both the signs. Remember, it's minus a -8 here. And then the second x value is the 3 minus the first x value is the -2. This is like adding the opposite. Same thing down here. So that looks like it gives me a 10 over a 5, which gives me a 2. So I know the slope on this one is a 2. And that's it. If I look at the next one, anytime I'm given a graph, I want to use the old rise over run for this thing. So I just kind of count down and over. So on this one, it looks like I have to go down and then over to get from one point to the next. It looks like I go down 1, 2, 3, 4, 5, 6 units. And then I go over 1, 2, 3 units. And because it was down 6, I use a -6 for my slope when I do the rise over run. So the slope is -6 over 3, which gives me a -2. Okay. Alternatively, for each of these, you could also think of it in terms of change in y over change in x, looking at the differences between the two. But really, that's more of a mental math way just to do the same thing we did in question 1. Okay. If we look at the next one, it asks us to find the x and y intercepts of each of these. And so on this first one, we're given the graph. And remember, visually, the x and the y intercepts is where it crosses the x and the y axis. Remember that our x-axis is this one, and our y-axis is the vertical axis, the one that runs up and down. And so right here, I've got the x-intercept is right here at -5. The y-intercept is right here at +4. And we should always write those as ordered pairs. So the x-intercept is -5, 0. The y-intercept is 0, 4. And one of the reasons we always want to write those as ordered pairs is because algebraically the x-intercept is when y equals 0, the y-intercept is when x equals 0, and I can see that with these ordered pairs. Well, that helps me with the next one because the next one, if I want to find the x-intercept of this thing, to find the x-intercept, I have to plug a 0 in for y. And then once I plug that 0 in for y, I just have to solve for x here. Sorry, that 8 was a little ugly looking. There we go. So now I get a 2x equals a -8. Sometimes folks call this the cover-up method because they do mental math and they just cover up that y value. But essentially what we're really doing is putting a 0 in for y. Now I divide each side by the 2. So it looks like I get an x value of a -9. Again, when I write that as an ordered pair, I plugged a 0 in for y, and it gave me a -9 for x. So it's the ordered pair -9, 0. To find the y-intercept, now I plug a 0 in for x. And now I'm going to solve. This leaves me with just a -6y equals a -18. Again, some people will just cover up that x value and solve for y in their heads. But if I just write this out, I'm dividing each side by that -6. I find out that y equals a 3. And again, I plugged a 0 in for x, and it gave me a 3 for y, so it's the ordered pair 0, 3. Always write these as ordered pairs. It's a great idea, and you'll make less mistakes that way as you go to do some other things. Okay. The next couple asks us to write this in slope-intercept form. And really, slope-intercept form, I just want to solve for y for each of these. And so the first one, oh, sorry, it asked me to write in slope-intercept form and then identify the slope and the y-intercept. So slope-intercept form, remember, is y equals mx plus b. And to put things in slope-intercept form, as I mentioned, you always just solve for y. So if we look at the first one, it's already solved for y. It's already in the format y equals mx plus b. So in this scenario, the slope is this guy, the -3/2. The y-intercept is this guy, it's the -10. But then we still want to write it down here, -3/2. When I write that y-intercept, again, I'm going to write it as an ordered pair. It's 0, -10. Don't just write it as y equals -10 or b equals -10. Write it as the ordered pair. Okay. This one, it's not in slope-intercept form first, so I have to solve for y. The first thing I have to do is get rid of that x value, so I want to move it to the other side. Whenever we're moving something to the other side, it's always going to be adding or subtracting. Since this is a positive 7x, I'm going to subtract the 7x from each side. And as I do that, I want to try to write this in the proper order here. I wouldn't write this as negative 28 minus 7x. I want to write it as negative 7x minus 28, okay, because I want the x value written first. And now I do my division. That's the distributive property. So here I get y equals, that's going to be a negative 7 over 2. I divide the 7 divided by the 2. And then I also do the negative 28 divided by the 2, which gives me a negative 14. And so now the slope is a negative 7 over 2. The y-intercept, again, as an ordered pair, is 0, negative 14. This one, again, if I want to solve for y, I got to move that one piece over to the other side first. So I'm going to subtract that 3x. Again, the 3x is positive. It's the y that has the negative value, so that just stays as a negative 8y. But I subtract that 3x. Once again, I put it in the proper order, negative 3x plus 48. And now I'm going to divide each side by that negative 8. And once again, I have to use my distributive property here, so I have to divide each piece of this. Negative 3 divided by negative 8 is a positive 3 over 8. Again, negative divided by negative is a positive. 3 over 8 is just 3 over 8. And then here 48 divided by a negative 8 is a negative 6. So now the slope is a 3/8. But the y-intercept is the ordered pair 0, negative 6. Because now it's in slope-intercept form. Okay? The next couple, it says to tell whether each equation represents direct variation. If so, identify the constant of variation. Remember, direct variation is of the form y equals kx. Really, it's the same thing as y equals mx plus b, but the b value is 0. Instead of saying slope, we say the constant of variation. But it's the same thing as what we did in the previous examples. I have to solve each of these for y and see if it falls into that format, see if it's a line that passes through 0, 0. So here I subtract the x from each side. Again, just like I'm putting it in slope-intercept form. And now I'm going to divide each side by the 4. Here I have to use my distributive property to divide that. So that gives me a negative 1/4 x plus 1. And so when I look at that guy, it's in y equals mx plus b format, but the b value is not a 0, so that is not direct variation. So no, this one is not direct variation. Okay? It's a line, but not a line that goes through 0, 0. This one, I'm going to solve this thing for y, so I'm going to add that 1/3 x to each side. Again, anytime I want to move the x value, I have to add or subtract, depending on whether it's positive or negative. So now I've got a 1/3 x, and now I have to divide each side by a negative 1. So I end up with y equals negative 1/3 x. And so this one is direct variation. It's in that format y equals kx. It's a line that goes through 0, 0. So yes, this one is direct variation. And the k value, the constant of variation, is the same thing as the slope. It's the negative 1/3. The next one, again, I'm going to rearrange this thing. I'm going to solve it for y. So I'm going to subtract the 3x from each side. And then I'm going to divide by that negative 3. So I'm just solving it for y. So it's the same thing I've done in the previous examples. But this time I'm seeing if it's direct variation. So that gives me a positive 1x. And so now that's in the right format. It's a line that goes through 0, 0. So yes, this one is direct variation. And the k value, the constant of variation, is a 1 this time. Again, it's the same as the slope. Okay? The next one, it says suppose y varies directly with x. In other words, it's saying that this is direct variation. And so there's two ways we can approach this. I'll do it twice here. But the first option for this is, remember, with direct variation, we can write the equation. We can say, hey, I know it's direct variation, so I know it's y equals kx. And then it gives me an x and a y value to plug in. So it says, hey, the x value here is a 10, and the y value here is a 5. Well, now I can easily find out what the constant of variation is. I can solve for k by dividing by 10. And if I do that, I end up with k equals a 1/2, which means the equation for direct variation this time is y equals 1/2 x. So then given the second piece of this thing, they give me an x value. Well, all I have to do is plug it in to get the y value. So if I plug that x value in, I get y equals a 13 over 2. And that's it. There's the y value. The other option for this is, remember, because direct variation goes through 0, 0, it makes all of the ordered pairs proportional when we talk about direct variation. So what I can do is I can set this up as a proportion as y over x equals y over x, and any y over x value will work here. So the values they gave me was 5 over 10. Well, I can say that equals y over x again, so y over 13. And so because the ordered pairs are proportional, I did the first y value over the first x value equals the second y value over the second x value. Now I can solve for y. I cross multiply. And so when I cross multiply here, I end up with 10y equals a 65. And now I have to divide each side by the 10. And the last thing I have to do is going to be reduce this fraction. So right now it's 65 over 10. Well, those are each divisible by 5. So that gives me a 13 over 2. Okay, so either come up with the k value, write your equation and plug in, or set this up as a proportion and cross multiply and solve. The next couple are just asking me a little bit about function notation. Remember, function notation, f of x or g of x or h of x or whatever you want to call it, it's the same thing as y, but it's a more powerful version of y. It's a y value that can also tell us what to plug in. So f of x is the same thing as y. So really this says y equals a negative 4x. But by saying f of x equals a negative 4x, we still have a y, but I can also tell you what to plug in. So down here at this first example, when it says f of 5, it's saying, hey, this is a y value, but it's telling me to plug a 5 in. So it's negative 4 times 5 this time. Okay, so function notation has that unique ability to tell us what to plug in. And now I can simplify. And just a reminder, this is not f times 5, it's f of 5. It's the function with a 5 plugged in, and that gives me a negative 20. And that's it. Just a little bit of simplifying. The next one, g of negative 2, it's saying, hey, take the g of x function, which this is like y equals 5 halves x minus 6. But instead of y, it's using g of x, so it can also tell me what to plug in. So g of negative 2 is telling me to plug a negative 2 into the function. So I plug a negative 2 in for x, and now I simplify. Here that gives me a negative 5, and negative 5 minus 6 is a negative 11. That's it. The next one is telling me to plug a 6 into the g function. Remember the mental math approach for multiplying fractions? That fraction, the 5 over 2, is like times 5 divided by 2. So you could do 5 times 6 is 30, divided by 2 is 15. Or you can do the division first. 6 divided by 2 is 3, times 5 is a 15. Either way, you get a 15, but that's the mental math approach to multiplying these fractions. And now when I do the subtraction, that gives me a 9. Whew. The next one's asking me to plug a 7 over 2 in for the x in the f function. So f of 7 over 2. Saying, hey, plug a 7 over 2 in here. And now I'm just simplifying. A little bit of order of operations. And again, that mental math approach, you can either do negative 4 times 7 and get a negative 28, and then divided by 2 is a negative 14. Or do the negative 4 divided by 2 and get a negative 2, and then times the 7 and get a negative 14. Again, the fraction just means multiplication and division happening simultaneously, which means you can do the multiplication or the division first in that situation. But again, fraction bars are just division bars. All right, so graphing these things. The first thing we want to do is kind of identify what format the function is in, because that'll determine the best way for graphing this thing. So in this one, I'm looking at it and I can see that this thing is in slope-intercept form. So the best option is to say, okay, here's my y-intercept and here is my slope. Okay, and if I just use those two things, sorry, my hand must have bumped the, whoops, and now I jumped way down. Let me scroll it back up here. There we go. So this one, the y-intercept this time is a 1. So again, write it as that ordered pair. It's 0, 1. And then the slope this time is negative 3 over 2. And remember, always just drop that negative with the numerator. It's always easier to think of that way. So now if I plot this, 0, 1, right here. And then the slope is giving me directions to the next point. It's saying go down 3 and over 2. And that's where you'd plot the next one. Then you can continue that pattern down 3 over 2. Or go in the other direction, up 3, back 2. All right? And, it's always good to graph a couple extra points to make sure you can draw the line in a straight manner. Okay? The next one's in standard form. Remember, when we're in standard form, the best thing to do is find the x and the y intercepts. Most of us use a little bit of mental math for this. So if I plug a 0 in for y here, I'm going to show a little bit of it, but show the process in terms of mental math. That would give me a negative 4x equals 8. And then you divide each side and get x equals a negative 2. So that's the ordered pair, negative 2, 0. The next piece, we would plug a 0 in for x and solve for y. And again, most of us would use mental math for this, but I'm going to show a couple of the steps here. Then divide each side by the 2, so y equals a 4. And again, that's the ordered pair, 0, 4. And so now I just plot each of those ordered pairs. So negative 2, 0 is right here. 0, 4 is right here. And that even gives me the slope. We can count it's up 4 over 2. So think of it this way. If it's up 4 over 2, that's a slope of 2. So up 2 over 1, I can even fill in the gaps. Up 2 over 1, I can expand this thing down to back 1. And now graph my line. Okay? Oh, that was a terrible line. I can do better than that. I believe in myself. And I believe that I can draw a straight line. Wow, it was worse the second time. One more time. Third time's a charm, right, people? Okay, well, I'm going to quit after that one. All right? Probably my best one, but there we go. All right? But again, plot those guys and then use the slope to make it a little bit more accurate. For the next one here, oops, went a little too far. Sorry, my mouse is having a little trouble scrolling today. All right, so this one, we've got y equals negative 2. Remember, y equals is the equation of a horizontal line. So I go to negative 2 on the y-axis. That's my y-intercept right here. And then I just graph a horizontal line. I just go from left to right, and I graph a horizontal line, and that's it. And again, the reason y equals negative 2 makes sense as a horizontal line is look at each of these ordered pairs. This one is 0, negative 2, 1, negative 2, 2, negative 2, 3, negative 2, 4, negative 2. The y value is always a negative 2. That's what happens when you graph a horizontal line. We get a y value that remains constant. Okay? This next one, once again, it's in a standard form. So the route to go here is to do the x and the y-intercept. Again, if you use a little bit of mental math here, plug a 0 in here, that's y equals 6. And now plug a 0 in for y, that gives you x equals 6. But then write them as ordered pairs. This is 0, 6. This is 6, 0. And now I can plot each of these. Now let's see, 1, 2, 3, 4, 5, 6 is right around here. And right here. And then again, it's down 6 over 6, or that's down 1 over 1, down 1 over 1. And we can use our slope to kind of plot this thing. Fill in the gaps. This one would also be really easy to put into slope-intercept form if you subtract that x from each side. So I'll show that way as well. And if you feel more comfortable doing that, that is fine, just fine. But you can subtract the x from each side, and then you get y equals a negative x plus 6. Well, now the y-intercept is a 6 and a slope of negative 1, which is what we discovered by doing an x-y chart anyway. Okay? The next one, x equals 3. Remember, x equals, if y equals is the equation of a horizontal line, then x equals is the equation of a vertical line. So this is going to be a vertical line here, so I'm going to plot the point where x equals the 3. So right here, so that is the x-intercept, and now I draw a vertical line. And again, the reason that makes sense is think about the ordered pairs. It's 3, 0, 3, 1, 3, 2, 3, 3, 3, negative 5, 3, negative 8. Okay, the x value is always 3. All right. The next one, this one is in point slope form. Remember, point slope form is this format. Let me write it off to the side here. It's y minus y sub 1 equals m times x minus x sub 1. where that x sub 1, y sub 1 is an ordered pair. And notice the minus signs built into the formula. That means we have to take the opposite of what we see. So in this one, the ordered pair that they're giving us is a positive 3 and a positive 2. Okay, so the x value comes from where the x is, the y value comes from where the y is, and then the slope this time is a 3 over 2. So instead of starting at the y-intercept, I start at some point that's on the line. This time the point happens to be 3, 2. So 3, 2 is right here. And then a slope of 3 over 2, so up 3 over 2. And really, the slope and the point having the 3's and the 2's is completely unrelated. It's a coincidence in this particular example. Okay? And I missed a little bit. I think I can do better than that. I think that point down there threw me off. There we go. All right. The next one asks us to find the missing value. This is one that students tend to really struggle with. And I think that's because, just the fine little details here. We're just using our slope a little bit and our slope formula. And so here, if I kind of write out the slope formula, remember it was y sub 2 minus y sub 1, so 9 minus a negative 3. And then x sub 2, which happens to be an x value this time, minus x sub 1, which is a 2. That's my slope formula, so it should equal the slope. And again, I'm going to write that negative with the numerator, so it's negative 4 over 3. I know from here we have to just simplify a little bit. 9 minus a negative 3, that's like adding the opposite. So that's a 12. So I get 12 over x minus 2 equals negative 4 over 3. Well, what I have here is a proportion. I solve proportions by cross multiplying. So negative 4 times x minus 2, make sure you distribute. That's a negative 4x plus 8. 12 times the 3, that's a 36. And now I can go ahead and solve this thing. So I'm going to subtract the 8 from each side. And I'll divide by the negative 4. And I find out that x equals a negative 7. All right, and really easy to check. You can plug that negative 7 back in up here, and then check your slope. Do your slope formula again, or do change in y or change in x. When you do that, this one is going to give me a 12 over a negative 9, which does reduce to a negative 4 over 3. So that's kind of my quick check for this thing. Okay, it's just finding the slope with that point plugged in. The next one, same kind of thing. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And when I do that, it should equal the slope, which is a 2, which is 2 over 1. And now just a little bit of simplifying down here in the denominator. Again, you can change this to adding the opposite. So that's a negative 4 minus y over, looks like a negative 5. And I'll cross multiply. 2 times negative 5, negative 4 minus y times 1. So you get a negative 4 minus y equals a negative 10. And now I can finish solving this thing. I'm going to add that 4 to each side. Now divide by negative 1. So I find out that y equals a positive 6. And once again, if you plug it back in up here, and you can do change y over change in x, or you can do your slope formula, what you should end up with here is a negative 10 over what looks like a negative 5, which does give me a positive 2. So there's my quick check. Okay, find the slope. The next one here says to start a long loan business, you invest $1,540 in supplies and charge $55 per lawn. So the first thing says write an equation that models your profit. This equation is going to be in slope-intercept form. Notice that per lawn thing right here. Remember, when we talk about rates, it's $55 per lawn. That is a rate, which means that is our slope for this one. So the slope is going to be 55. And so if you want to do this as y equals mx plus b, it would be y equals 55x. But then that b value is a little tricky. It says you invest $1,540, which means you will instantly lose $1,540. So we put this as a minus $1,540. $1,540. We're starting $1,540 in the hole, in the negative, okay? And we have to mow a lot of lawns in order to make up for those supplies we had to buy, okay? So this is my equation. The second part of this is how many lawns must you mow to break even? And the hint here is that breaking even is when profit equals 0. Well, for our purposes, profit was the y value, and x is how many lawns we mow, all right? So if y is the profit, saying, hey, plug a 0 in for y, and now we can solve this thing for x. So we add that 1540 to each side. And then we divide by the 55. So it looks like we get a 28. So it's saying 28 lawns. And that's just how many we have to mow to kind of break even, to pay off the debt that we created when we bought all the supplies. All right. The second part of this, or the third part of this thing, the last piece of this, is it's asking, what does that break even point represent on our graph? And so this is kind of a question about, what did we just do? We just plugged a 0 in for y. Well, plugging the 0 in for y means we're finding the x-intercept. Okay, so the break-even point is the x-intercept on the graph. All right, and we know it's the x-intercept because the x-intercept is when y equals 0, and that's exactly what we just did. We just plugged the 0 in for y. Okay. For this last one, it says a scissor-lift can raise and lower a platform from 48 inches to 252 inches, and so that's an important note that we want to jot down here. So we're going from 48 inches to 252 inches. So we're starting at 48 inches and we're ending at 252 inches. And then it also tells us that the rate at which it raises, and that's important because they're calling it a rate, is 2 inches per second. So that's the rate, that's the 3.5. And so as we write the equation for this thing, we know right away that that 3.5 should be our slope. So it's y equals 3.5x. And then as we look at the values it gave us, the starting value is 48, so that's my y-intercept, okay? The other thing I have to look out for here is it asks me to write this in function notation. So instead of y equals 3.5x, we can do something generic if we'd like f of x equals 3.5x, if we want to kind of keep it in that very math type format. But honestly, it would make a little bit more sense because function notation, we want to use variables that make sense. It might be better to say h of something like t. In other words, the height based on time equals 3.5 inches per second, which is time, plus the 48. And so either one of these second two will work because they're each function notation, but this guy really makes sense from a real world perspective. Okay? So the next thing we want to do is graph this thing. And the graph of this might be a little bit tricky, especially with a slope like 3.5. I might have to kind of think about this slope a little bit. 3.5 over 1, that's the same thing as like 7 over 2. And so as I scale this thing, I'm going to put time down here. I'm actually going to go by 2's on time, so 4. So each block is 2. 8. And part of the reason I'm going by 2's here is because, again, if you think of the slope as 7 over 2, moving by 2's in terms of my blocks is a pretty decent idea. Okay. And so now over here for my my height, I'm going to scale the height. Oh, and I guess that was in inches, so I'll just write inches over here. For my height, I'm going to put a little zigzag in here. That means I'm just skipping some values, so I'm going to start at the 48. It's nice to start at the 48 because that's my y-intercept. And then I'm going to scale this thing by like something like 7's or 14's. I think 7s might be a little low, so if I scale it by 14s here, or no, sorry, let's go 28. I want to go a little bigger here. So I'm going to scale it by 28s, which seems a little bit silly, but it's a multiple of 7, and my slope is 7 over 2. So if I go by 28s, I think it'd be pretty good. I get a 104 here, 160. And I'm just labeling every other, only because that's easier to do. And I'm really just hoping to make sure I get that 252 included here. And it will be right around here. Okay, I don't need to go any higher than that. So now as I plot this thing, so right here, that's 48. And then from here, again, the slope, because it's up 7 over 2, well, each block is worth 28. So that's like going up 28 and then over 8. So I could go here. And then up one more block, I could go over another 8. And again, it's just kind of reimagining this slope. Well, that's 28 over, sorry, I said over 8. I meant over, yeah, over 8. Sorry. And I can just keep that pattern going. And that's kind of why I scaled this the way I did. You know, there's some other ways that I could scale it. And then probably one more get me to the kind of the top of this thing. I draw my line and notice it stops here at this end. I don't want to go into the negative, so I don't want to draw an arrow. And actually, if I can kind of continued this a little bit further, actually, I don't even want to go that far when I think about it. Let me back this up a little bit. Because remember, the scissor lift can only go to 252. Oh, no, I guess that was probably around 252 where it was. So we'll keep that line the way it is. But we're kind of stopping at some point. And we don't know what that value is in terms of time, but you know, this thing does not go on indefinitely. It stops at some point. And whether or not I can see where that stops right at this moment or not, that doesn't really matter. I'm going to assume it stops right around in there somewhere. So then the domain and range, we kind of want to solidify that idea of where does this thing stop. And so when we look at the domain and range here, we know where the thing starts. Sorry, this thing is being really squirrely. We know that it starts in terms of x when we look at our domain here. The domain goes um, from 0 to something, but we don't know what it is quite yet. And so I'm going to say the domain is x such that, well, it starts at 0, that's the time, and it goes to some unknown value. I don't know what that is yet. So now let's jump to the range. The range is the easy one because they gave us the range right out of the gate. They said it starts at a height of 48 and it ends at a height of 252. And so remember that relationship between domain and range, if it ends at 252, we need the time that goes with that. In other words, you got to take 252 and plug it in here and solve for the time. And see, this will give us the maximum time because the maximum time will kind of go with the maximum height. And so I'm going to subtract that 48 from each side. And then divide by the 3.5. So let me try scrolling down just a little bit, see if this thing will cooperate. And this is probably a job for my calculator. I don't think this one's going to work out nicely. But if I plunge this into my calculator, the 204 divided by the 3.5, oh, it gives me something really ugly. It gives me a 58.29. Not seconds, but that's the maximum for my time up here for my x values, for my domain. Okay, And keep in mind, we could also write this if we wanted to in interval notation. I know some of us are really big fans of that. So it'd be a bracket for the equal to condition on the 0, and then we would go to 58.29, then a bracket for the equal to condition on there. It starts at 0 and ends around 58. And then the range would start at 48, including the 48, and end at the 252, including the 252. Okay? So again, thinking about where this thing starts and where it starts and stops in terms of the x, where it starts and stops in terms of the y. All right? Hope this was helpful, and good luck on your test.